So this is Arlo Belshi. This man is really, really smart. We were having beers together in Boston, and he told me about this method. And I was like, oh, my God, that's brilliant. And then I went home, and I tried to do it, and oh, my God, I couldn't do it. But I helped run a conference out in Budapest, and so I'm like, Arlo, come to Budapest and give a talk on this process. And fortunately, this was videoed, and he gave this talk. By the way, that whole notation came out of this talk. It was like 30 seconds in the middle. But that talk, while being great for our industry, was not that helpful for the audience, and I have been spending about the last year trying to decipher what he said into things that humans can use. And I think I finally got there, and that is what I'm going to talk about today. The idea in general here is we're going to take a big block of code, legacy code, so badly formed code, and we are going to convert it, ooh, I'm missing the second part of that, into pipes. Right. And then once we've converted it into pipes, so we have a data flow through the thing, we can turn the entire thing to asynchronous in a single, like it's going to be 4 characters to change the entire thing asynchronous. And almost everything we're going to do is a very, very low risk refactoring that makes it very easy to do it. This comes from Kent Beck's, like, make the thing easy and then do the easy thing. Warning, the first part might be hard. All right. I've been doing this with Jay Bazuzzi. He's a developer up in Seattle. Really great guy. This is the first time like we're really talking about this stuff, so it'll be interesting to see how this all goes. Code to data. This is the pattern that we are going to use. And I'm going to do most of this session is just going to be live demo. All right. By the way, most of the session is going to be in C#, but all of the sessions are going to be in C#, but the pattern works regardless. So let's go and take a look at this. Not that, not that, this. All right, so I'm just going to copy this. And let's move to the code. There we go. Okay. So we're going to start with this nice little sample code because it's nice to start easy. So you can see here that I have a zip code that comes in. And this zip code goes to a service to get some available peanut butters. And it goes to a service to get some available jellies. And then from the resulting peanut butters and jellies, I get the best peanut butter and the best jelly. And I combine them in my sandwich to create the best sandwich. And then I return the best sandwich. Fairly simple code, but almost everything here is dependent on external dependencies, which makes it almost impossible to test. And if I start moving this asynchronous and do it step by step. So one interesting thing to do is if you do things asynchronously in parallel, it is not a valid refactoring, right? You can get very different results from doing that, right? Now, I believe there should be no problem going asynchronous on this. This is one of the reasons I'm going through this process. However, the reality of legacy code is there are hidden dependencies everywhere, right? And that's why I want to like really separate this risk. So I got a unit test. The unit test is going to call this, right? And you know what? I think I can turn this off and then I'll just run this. So let's give this a run. Did it run? Yes. Good. Okay. And da-da-da-da-da-da-da. Wants to go really slowly. Really, really slowly. Yay, it doesn't work because we're not connected to the service. Not too much of a surprise. It's hard to test things that have lots of external dependencies. Anyhow, we are going to go into this sandwich and we're going to paste in that code. This is what we're going to do. Oh, that's weird. Oh, I have show in white space on. Nice. Okay, here's the pattern. We're going to do this line by line. We're going to copy the line. We're going to move it into the pipeline. And now we're going to convert it to a pipeline. Now this is the very first one, so we have no starting pipe. So we're going to have to do a little bit more. Because we want to take the thing that's in the middle and grab the pipe version of that, and that doesn't exist right now. So I'm going to copy that again and go above. And I'm going to create a zip code pipe. And that is always going to be a new input pipe of zip code, or whatever the thing is that you're doing. And it needs a name, so how about zip code? Notice the utter lack of creativity. That's going to be a theme. This is going to produce a peanut butters pipe. And you need to send stuff through your pipe, so let's take that zip code pipe and send a zip code through it. But the problem now is I sent something through the pipe, but I haven't gotten the thing that came out of the pipe, and I need this peanut butters. I'm trying to replace this line. So I'm going to take my peanut butters pipe, and I'm going to collect that is weird. What is going on? Let's try it again. Pipe is a what? No. Oh, thank you. Thank you. I didn't actually pipify this. So, the thing in the middle goes to the front. It adds the word pipe. And then this is actually a method, so you have to actually say process function. And instead of calling the actual result, we're calling a delegate to that function. Thank you. So now we have a pipe that comes out of it. And now we're going to take that peanut butters pipe, and we're going to collect from it. And that is going to give us a peanut butters collector. Everything fairly straightforward so far. And then what I want to do is take this and say, hey, in that peanut butter collector, whatever came out of that, that's the same thing. So I have now took one line of code and expanded it to 5 lines of code. Woo! So, the first question you're probably asking is why? Why, Llewellyn? Why would you ever want to do that? And the first thing I just want to say is, like, trust me a little bit on this one. I know it sounds crazy. But what we have done is we have made something that can now easily be asynchronous. It's still synchronous, right? But it is now, we've taken what is effectively the semicolon operator and taken the logic of our code, which only existed in code, and now it made it exist at runtime, right? So the logic of how stuff flowed through only existed at compile time. Now it exists on runtime, which means we can do interesting things on it. Like, hey, did we do this right? This sounds really weird, but let's put some unit testing directly in the middle of our production code. Not a thing you normally do, but something we use quite a lot in this particular process. So this is approval tests. That's a whole nother talk for right now, just go with it. And let's verify the zip code pipe. And since this is now runtime information about your code, you can dynamically display it. I'm going to put a little reporter here. So use reporter, type of dot reporter. And I don't know if people are familiar with dot files, but it is a way of describing workflows. All right, so now let's run that test again. And it's going to fail still, but we now should be able to visualize what our system looks like. So here it is popping up in Visual Studio Code. This is the dot file. It might be a little hard to read that, so let's visualize it directly. And so we have zip code coming into our system. It goes to this method on getAvailable peanut butters, and it kicks out peanut butters. Also, the output of this is getting collected. That's exactly what we expected that line to do. So yay. I'm not going to verify this yet or approve it, but I've now made a single step. Now I can't check this in. Oops, sorry. Let's go back to here. I can't check this in because it fails at the moment, right? But what I could do is comment out that. And now I can check in this very small change to my production. It's not a provable refactoring, right? But it is a small independent refactoring of just convert peanut butter to pipeline. All right, so now let's put in the ability to see this again. Yeah. And let's do the next line. So again, same process. We're going to copy the line. We're going to move it up to the top, paste it. We're going to put the word pipe in front of it, and we're going to take the thing in the front, put it to the front as a pipe. Then we're going to process. This is another function. I'm going to process the whole function. And I've now converted this to my pipe, but I want to replace this line, so I need to collect from it. So let's take my jelly pipe and collect from it. And we will call this a jelly's pipe collector. And now that I've collected from the pipe, I can go down to this line and replace it with my jelly's pipe collector and dot my single result. Now, did this work like the way that I expected it to? Let's run our test. And again, now that we're converting what was compile time information into runtime information, we can visualize it. Later on, we're also going to find that we can move it easier and we can unit test it easier. So again, not so easy to see in the dot file maybe, but in the preview, all right, let's try that again. In the preview, we can now see, let's see the best way to do this. Do that? No, those buttons do not seem to work. All right, zip code comes in, goes to the peanut butter, and goes to the jelly. And again, right now, it's doing this synchronously. It is not yet asynchronous. Gives me peanut butters, gives me jellies, both of which get collected. Yay, that's exactly what that code should do. So, fingers. Let's go to our simple calls. Again, I'm just going to comment out the test that's going to break everything. And I'm going to commit again. Extracted jellies to pipe. Is that working? Commit. Oh. Commit. Yeah. All right. Oh, that's why I didn't like that. Let's try that again. There we go. Okay. Next, let's take the next line. Now, there's two ways I can take this next line. We'll start with just the most basic. Is that a question? No. Okay. One is, so let's pop this line up here. Notice that we are doing a transform on peanut butters and a transform on jellies. I could extract those as separate steps. The best way to visualize that would be if I was to extract this as a variable. Right? So I could make that a separate piece, or I cannot. In practice, the way that's going to occur is, do I think that this is a interesting transformation or not? If it really is just a getter, I'm probably not going to transform it. If it's a call to another service, then I'm definitely going to extract it as a separate pipe element. I'm not going to do it right here. So again, I have peanut butters. So peanut butter's pipe. Oh, but I also need jellies. So let's join to the jellies pipe. And then I'm going to process, not a function this time, so just a regular process. And something that takes peanut butter and jelly. Yeah. What are you doing to me? Peanut butter and jelly. And creates a sandwich with the best peanut butter from the peanut butters and the best jelly from the jellies. And what does this give me back? It gives me the best sandwich pipe. And of course, I need this thing to come out of the sandwich pipe, so let's take the best. Oh, that worked anyways. Good, yay. Collector. And var that. And this gives me the best sandwich collector. And now I can take this, and instead I can here say best sandwich collector dot single result. And if I run this, I should now see the entire process. Eventually. All right, there we go. So, this is our process. We have our zip code. It goes to the peanut butter shop. It goes to the jelly shop. It gives me peanut butters and jellies, which combines together into a tuple of peanut butters and jellies, which then goes through a crate with the best peanut butters and the best jellies, which gives me back a sandwich. So one of the things that Brian Beacom actually observed as a pattern, which is really useful. Oh, right, yeah, so an example would be helpful here, is this EPIC pattern. Identify, prepare, improve, clean up. When you are doing refactoring, this is usually the pattern that appears. You identify something that can be better. Usually, you have to prepare it. You've been seeing me doing a lot of prepare. Now it's been improved. It's now time to clean up after myself, right? Most of the time in the process of refactoring, you will create a lot of cruft. So let's go and clean up. Well, before we do that, let's check in. So do that, save that, and extract. Sandwich pipe. All right, so first of all, you'll notice that peanut butter is dead. You can tell because it's gray. All right, so we can just remove that. Jelly's also dead. You can tell because it's gray. By the way, so that is in and of itself like a provable refactoring, right? Because my tooling is actually the one that's giving me the proof. So I could actually use like a lowercase r here. Delete clutter. Hey, and look, I can delete jellies too because that's garbage. And hey, look, that's also delete clutter. And look, this might as well inline, so let's just inline that. And again, provable refactoring because I'm using my tools. So inline. And now look, now that I'm not pulling it out, this collector is also no longer needed. So I can delete that. I can delete the whole thing. Question?
I have a question about like the central pipeline, the zip code pipeline, what are the other ones?
Everything is the zip code pipeline. Well, I mean, they're going to other parts of the pipe, but this has a single pipe starting point. That's not always the case. There can be multiple input points. There can also be multiple output points. We'll talk about that. So delete clutter. This is also now junk. So we can delete clutter. Ooh, that did not do what I thought it did. Delete clutter. Oh, I didn't save the file. All right. So now we have sort of the single pipe, right? We don't really need this approvals thing in the middle, right? We set up our pipeline, we send through the pipeline, and then we return the result. There's a nice little trick you can do on this. So you can take that zip code pipeline and get the inputs, right? Our inputs are a zip code, and the outputs. Our outputs are a sandwich. And that will give me my inputs and outputs, right? In this case, inputs 1, outputs 1, and there's 1 input, 1 output. And then I could replace this with inputs and outputs dot send, and I can replace this with inputs and outputs dot output 1 dot send result. Yeah. And that means that I can take this entire part here and extract it as a method. Set up pipeline. Yeah, I can set it up that way, but let's do it not as a property, but as a method. That's better. Actually, not even set up, just get pipeline. And let's make that public. So now, this is the business logic-y part, and this is my execution of the part, right? I get my pipeline, I send stuff, that is not quite what, let me undo that for a second. Let's include the inputs and outputs on that one. That was a little bit glib. Get pipeline. So now I have the part where I get my pipeline, I send through the pipeline, and I return the result. Right? Which means like these comments have kind of lost their value. Publicize that. All right, so let's go to GitHub and unprovable extracted pipeline setup. Now, the interesting thing is, even though all of these are dependencies, this pipeline doesn't do any of them because it doesn't actually execute them. It just sets them up, which means I can actually now take my unit test and change it to just be a pipeline approvals dot verify simple calls dot get the pipeline. Ooh, not what I meant to do. Don't need any of this. Let's give that a run and make sure I've done everything correctly. Right. I wouldn't, would be the answer. I'd make it public. So there's this like gets into this whole other aspect, right? How many people here have seen The Matrix? Okay, good. Spoilers if you haven't. There's a scene in The Matrix where Neo is on the roof, and the agent is shooting bullets at him, and he like time slows down, and he like avoids the bullets, right? That Neo dies. Don't be that Neo. That Neo is someone who is playing an Earth as a very, very good user. Right? You want to be the Neo at the end of the game, right, or the end of the movie, when the bullets are coming at him and he stops the bullets. They don't render this as nicely in the movie as I wish they did. But what's really going on is Neo is realizing I am not a user, I'm a programmer. And as a programmer, I am a god in the computer. And so he sees this field on bullets that's private, called speed, and he turns it public, and then he sets it to 0. The code is supposed to serve you. If it's hard to test, change the code so that it's easy to test. Don't change yourself so you can test hard code. Inconclusive, of course. Sorry. Let me do this on the output. Output 1. So now it's going to run this test. It's going to come up, hopefully, with the exact same diagram we had a second ago. But now my test code is not sitting in the middle of that function, because I can now get through that entire function. That did not pop up. What's going on? Get output 1 dot. Oh, that should have totally worked. Parents of 0. Is that going to work for me? I'll try that one more time. Inconclusive is a really unfortunate test error because it doesn't actually tell me why it's not running the test. I assume I'm doing something weird here. Yeah, all right. Inputs, outputs, return the inputs, outputs. Yeah, all right. I'm going to figure this out later and just ask you to trust me that this can actually work.
Where did you set your zip?
Where did I set my what?
Zip number.
I don't have to set my zip code because I'm not sending anything through the pipe. I'm verifying the pipe. I'm not verifying the execution of the pipe. Does that make sense? Although I am assuming, let's see for a second, just a little bit of troubleshooting, even though that's a generally bad idea in a talk. So let's get the pipe and then do that and see if the test actually runs. I'm assuming my problem is in my verify. Nope. All right, my problem is here. Instead of starting on the zip code pipe, let's start on the jellies pipe. Ah, yay, unit tests are actually doing what they're supposed to do, just in a very non-intuitive way. Duh. All right. We'll let it go. But this is now what you're very, yeah.
So when you split that all up, do you find a performance impact?
Oh, at this point, no. There will be a performance, because all of this time, right, all we've done is convert this to be ready to move to async. So we do actually have to do the refactoring to turn it into async. So let's do that. We are using pipelines here. Actually, no longer should need approval tests. That's weird.
So if you have something like, splitting the steps out might slow it down with the making it asynchronous speeds overall thing up, or is there maybe there is no slowdown? I just
like the putting something into a delegate and calling the delegate as like a non-impact on your code. Like we're talking very few clock cycles, right? You're a C++ programmer, so I appreciate the fetish. However, notice like the number of clock cycles that occur there, right? So yeah, I'm adding in the tens of clock cycles to this. It doesn't matter.
Actually, I was just trying to understand.
Yeah, but so not a noticeable thing. The moment that it goes to async, it will make a noticeable difference because, of course, you're not blocking, but you might also discover dependencies that make it not work. So, but let's do that anyways. Okay, so we're using pipelines. Now it's asynchronous code. That is the actual refactoring to asynchronous. So remember that earlier statement, do make the change easy, then make the easy change. The first part might be hard. Like this is a complete separation of turning things to async versus preparing things to be mutable. Mutable is the wrong word. To be changeable. I mean, that's it. Like there's not more to how you turn it into async. Right. So the pattern is the same, regardless. Nothing we're doing here is actually C# specific at all. The one thing I would say, like, when we implemented this, we did take liberal advantage of is C#'s extension method. All right, so extension methods are a really nice aspect of the C# language. You can do all this without extension methods if you are in a language that doesn't have them, but you're going to have to manage your objects a little bit more, unfortunately. But that's basically the only thing that I would consider C# specific at all about this. The basic idea, again, you're going to create your pipeline, you're going to call your pipeline, and then you're going to return the result from your pipeline. All right. That's what we're doing. And all we're doing here is making a way that you can refactor this line by line. So this method can be 1,000 lines long, and you don't need to understand it at all. You just take the top line, convert it to a pipeline, the second line, convert it to a pipeline. Like, that's it. We're going to take a look at a much more complicated method in a second. Arlo, being Arlo, has a tendency to make all his samples. These are the hardest things ever, and if it works for this, it will work for your code. And that's great for Arlo, but not so great when you're trying to learn things. All right. Again, just breaking that down like a little bit more line by line. We're going to take line, copy it to the pipeline section. We're going to move the parameters in front to pipes. We're going to convert the call to a lambda or a delegate. We're going to create a local variable from the pipe. We're going to collect from the pipe. And then we're going to replace the original call from the collector. That is the pattern that you're doing. It's very, very prescriptive, which means it's great for legacy code, because being able to improve code that you don't understand is a really useful skill when you're in legacy code, because understanding legacy code is usually a luxury you don't get. Right? In fact, Michael Feathers did a project called Delta Flora. And in Delta Flora, he used static code analysis over code repositories over time, right? So going through the Git, like the source control history. And what he found is in most projects, if you look at single methods, they have a line count, and the line count goes up, and then it goes down, and then it goes up, and it goes down, and it goes up, and it goes down, until it hits a point. Now that point is different per company, but each company has sort of a point at which, after it hits that point, the line count never goes down. At that point, it only ever goes up. Right? And basically what is happening is the function is getting more complex than the employees can understand, and so they can't clean it up anymore. They can only add to it. And that is how you end up very well-known companies with 25,000 line methods in their main. Right? Like, these are smart programmers. They're able to do things. The fact that you can do anything in a 25,000 line method is impressive to me, but they are not programmers who've been trained on how to make maintainable code. In fact, very few programmers. This is an interesting misconception that I've just recently realized is people seem to think that programmers are good or bad based on what they can produce, and not realizing that your ability to produce something is completely tangential to your ability to produce something that is maintainable. And most programmers have no ability to make something maintainable. And so if you're going to start looking at how to refactor code, it's very useful to come up with skills that allow you to refactor code without the burden of having to understand the code you're refactoring. That understanding will emerge as you clean up the code as opposed to beforehand. Yeah?
You don't have to understand it. Why not use a machine?
To do it? So that's a really interesting question. The short answer is just because we don't have much that does that yet. However, not entirely true. What is this? PayPal guest? Can someone remind me of the password? It was like safe payments? Is that right? So let's change our language for a second and move to PyCharm. I think I'm doing this correctly. I have 2 versions of PyCharm. I forgot which one I set this up in. We will find out in a second. Apparently, Dropbox has something to do. Yep, don't care about that. Sorry, good. Okay. And let me come up with some sample code. Yeah.
I'm sorry, are there any kind of like, I don't know, guidelines or domains or requirements or something for what code you can factor with that method?
To pipelines? Not as far as I know, is the answer.
Because, I mean, I'm thinking if you've got something that's highly threaded and it's got...
No, so that's no problem at all because the first refactoring does not change the threading at all. So however it executes, it's going to execute exactly the same when you refactor it. When you convert it to async, that part is not a refactoring, right? That part might break. In which case you might need to look through, and basically what we usually do in that situation is we add the pipes of the actual dependencies. Like this thing actually needs to finish before this thing starts. Because it turns out this thing is setting some global field or touching a file or logging into a service or making a field in database or some kind of shared state that is required for this other thing to occur. All right, so this is the Gilded Rose example from Emily Bach. Here it is. And this is Sorcery. It's an AI refactoring tool. So I'm going to go and click on it and say, restructure and simplify the code. That's pretty awesome. Sorcery just came out. It's in private beta at the moment. It only works in Python. But, I'm very excited about what this holds. So your answer of why do we not have computers do it is simply right now because I don't have computers that can do it. But maybe we are on the edge of that, right? I have not gotten to try this in anger. None of my clients are in Python. I'm a legacy code technical coach. And when I get better at my job, I get worse clients. So most of my clients are in C++ and Cobalt and RPG nowadays, but I don't have any clients in Python. But I would love to try this in the real world. I'm very curious to see how this holds up in legacy code is interesting in what it will throw at you. One thing I do know is this will only do it per method. It will never extract a method. So if you start with a 1,000-line method, you will end up with I don't know how many lines of method, but it will still be a single method. It's not going to split your code out. But that doesn't mean you can't do it. It just means that part hasn't been written yet. And so, yeah, hopefully in the future, my answer is yes, you use a computer to do this. And we will be doing more interesting jobs. Where are we? All right. Why would you want to do this? The biggest one to me is separation of risk. Almost everything that I'm doing, all the time that I spent today, was very low risk refactoring of my code. That separation of risk is really important. One of the things I see happen in companies, and again, I'm a legacy code, so my sample size is biased, is people will start trying to refactor on their own. And if you refactor something properly, it does exactly the same thing it did as before you refactored. So your managers tend to not really care. But if you refactor something and it breaks, your managers tend to really care. And so when that happens, as it inevitably does if you do any kind of large refactoring, your managers will say, don't refactor. Right? And they will actively tell the programmers not to clean up the code, which is insane. Right? But this is what happens when the reward system is only based on what you see. Right? And because you can't see a refactoring, right, unless you look at the code, unless you measure how long it takes you to fix code or how much bugs, these are all future things. And as a general rule, we discount the future. That's especially true, by the way, if you are in something called tunnel vision. Tunnel vision is any time you're in something that's scarce. So if you cannot breathe, you do not give a damn about how much oxygen is in the room tomorrow. You only care about how much oxygen is in the room this moment. If you cannot eat, if you're starving, you don't care about how much food you will have next week. You care about how much food you have right now. If you're freezing, there's a great scene in Frank McCarthy's Angela's Ashes where the kids start chopping down the main beam of the house to put it in the fireplace. That's not a good way to stay warm tomorrow, but it's a great way to be warm today. If you're in tunnel vision, you discount the future to zero. And it's just a property of people. Now, most of us are not starving or hungry or freezing, but most of us are in tunnel vision scarcity of time. Most of us do not have enough time. And so, you will make really bad decisions to have time next week because you're trying to make it so you have enough time today. And that's just how people work. And so very often, this sets up in a company because companies love deadlines, right? Whether it's an actual deadline or not, they feel like deadlines are the way you get something done. So they put them on there, and then you're in a crunch constantly. And then you start doing things that help you get through today, even though they hurt you next week. And then that company exists for like multiple years, and all of a sudden you're in trouble, right? And so this separation of risk allows you to refactor things without having it cause trouble. You can refactor the entire code of pipelines, test it, get it really nice, and not do a single, first of all, test it without mocks, right? Which is super nice because mocks, while useful, are unfortunate. And then also do that whole thing without turning it to asynchronous at all, right? Just make it so that the moment you're ready to, you do. And if you only want to take a section of it, just take those few pipes. Don't change the whole namespace. Just take those 2 pipes and change those, right? So it gives you this real flexibility to do things safely. And I have found in legacy code, I value safety more than anything else. But it also separates the assembly versus the doing, right? That allows us to do things like make this testable. It allows us to do things like visualize it in those dot files. I believe it allows us to do a lot of other things. I don't know what those are yet. I'm still, as I mentioned, fairly new to this whole process. But my instinct is that there's a lot more that you can take advantage of the code once you convert it from just compile time to runtime. I'm curious and excited to figure out what those things are. So, customer wanted. This is a free and open source project. If you are using C# and you're interested in trying it out, contact us. Let us know how it works. Right? If you're in another project, let us know too. Like we can help you create the code there. I pair remotely a lot. So, if you're in other languages. But we would actually like to get some real world, we've been playing with this, but we've been playing with it on Saturdays. Right? And one thing I know is when you take something academic to the real world slaps you back. And I'm curious to see how this turns out in the real world. So if this is something that is interesting to you, try it out, but contact us. We would love to actually see how it's working, help you out with it. We were talking about what is our perfect customer. So if you have code with lots of dependencies, well, that seems like a good match. C#, as right now it's in C#. If you deploy frequently, it's going to be much easier. That safety becomes easier if you're deploying frequently. A large code base is going to be great. This is going to work better. I think it's going to be more helpful in a large code base. Small code bases, it's easier to do more ad hoc things. Have some decent refactoring and testing skills. They don't have to be amazing, but probably it's good to have some when we start. And then Jay and I do this on Saturday mornings. So if you want to talk to us, you have to have some availability on Saturday mornings. But if those are things that work in with you, get in contact with us. Resources. All this stuff is up on GitHub. All this stuff is open source. It's Apache 2, which is, I think, the easiest license model for everyone to use. Yeah. Just waiting for the phones to go down. All right. Okay, so we're at the end. We have 11 minutes. We have two things we can take a look at before we go. One is we can just take questions or end early. That's perfectly acceptable. The other is Arlo had this original test things the hard way. I'm going to show you what the code looks like and see if you would like me to go through this. I'm going to go through it much quicker, but if that would be helpful for you. So this is a harder piece. We have loops, we have for eaches. Is that helpful? Not helpful? What do you think? We got 11 minutes, 10 minutes. If you want to see me take 10 minutes of refactoring this, put your hand in the air. I don't know. Let's find out. If not, this is a good time to leave early. All right, so let's take a stab at it. So first of all, we're going to go to our unit test. We're going to mute this for a moment. And we are going to turn this on. And we're going to run that and just make sure that it actually runs. It should fail. Yay, failure. All right, so same pattern as before. I'm going to steal that template and paste it at the top. I'm going to take my first thing, put it into the pipeline. It has inputs from the file name. File name pipe equals new input pipe. This is a string. And then same thing here. Take that, move it to the front. This is a function, so process it as a delegate. Creates a character file pipe, which I then take the character file pipe. That's not what I was expecting. Character file pipe and collect it. Yeah. I have to send through that pipe. So here we have the file name pipe. And we are going to send the file name through it. And now I can take this last piece and change that to character file pipe collector, single result. There's my single step. And of course, I want to see that I'm actually doing something correctly. So I'm going to take the character file pipe. I'm going to verify the character file pipe. All right, let's see if that works. Oh, yeah. So let's put the use reporter type of dot reporter. All right, try that again. So again, if we did this right, we'll start to piece out how this code actually flows things through. There's an interesting aspect of the diagrams as well, which is you can show these to business people, and it should be what they are expecting. Right? Like this is a way of visualizing your code that a business person can actually interact with. All right.
Using the approval test as like a stepping stone, you don't keep down the road, but
So like in that last part where I extracted it, I'm putting the approval test in the middle of the function right now as a stepping stone because I can't get through the function, right? Because everything in the function calls services. And like, so as soon as I start hitting my dependencies, I can't actually do anything. Everything blows up. So I'm putting, as a temporary step, I'm putting the approval test in production so I can refactor cleanly. And then later on, I will move it to the actual unit test when I've extracted the pipeline cleanly. All right, so let's go back to our everything the hard way. So I did the first one. Let's do the next one. I'm going to put just like a line here to make it a little bit easier to see what I'm doing. So, same process. Paste. This is a character file, so I'm not coming from the same input pipe. I'm coming from the character file pipe. And I'm going to process. This is another function, so I'm going to pass in the delegate. And this is going to give me a config file pipe. And then I'm going to take this config file pipe, and I'm going to collect from it. And that is going to give me a config file collector. And now I'm going to take this, and that's going to become config file collector dot single result. So now my line moves up here, and again, if I've done everything right, we should be able to see stuff. Good. So now file name comes in, gets transformed to the character file comes in, goes to the config file. So, just keep going down. Parse cards on the character file. This is a little tricky. The character file is already in front, right? So it's going to be character file pipe dot process. This is going to be a lambda, so we'll do C goes to C dot parse cards. And this is going to back our partial cards pipe, which again, we need to collect on. That will give us, partial cards collector. And again, like, I am not getting any insights into what is happening below the lines I do not, this could be 1,000 lines long, it wouldn't matter, right? I don't need to understand anything beyond the one line I'm doing. Just move that line down, run that. And so now we have a file name comes into the character file, which gets split, goes to the config file, and goes to the parse cards. So we're going to just keep on chugging through. Take the next line, go up to the top. Again, this has the same pattern as before, so I'm going to pipify it, do a process on it. And again, C goes to C.parseCards. So now it's a lambda, and this is going to be the local cards pipe, which I am going to collect from. And go down to here and take this from the local cards pipe. From the local cards collector. So another nice thing about this is when I do it wrong, like it autocomplete stops working, right? So sort of like a nice little check for me is, does my autocomplete work? And again, should be able to visualize this. So now I have file name comes in, splits into the parse files and the config file, which gives me a config file, which I then go and parse again to give me a list of card data. This also gives me a list of card data. All right. Oh, we're almost out of time. So let's do the next one, compendium service. This one's a little trickier. So first of all, notice we need a username. So I'm going to new up a input pipe of username, which is also a string. That was a weird sound to get. So this is going to be my username pipe, which I need to send through, right? The username. And I'm going to need a password. So, another input pipe, also of string password. This will give me a password pipe. I then need to join these together. So let's call it credentials pipe equals the username pipe joined to the password pipe. And now I can take this and take my credentials pipe and process. This is a function, so we're going to delegate it. Oh, right, sorry. Yeah. And that is going to give me my credentium service pipe. We are out of time, so that's where we're going to have to end this one. But as you can see, it doesn't matter that this is a crazy long and complicated function. This process just chops through it. Yeah. Thank you.